Hello guys. In this video I will be showing you a review previous to the exam. But I'm not gonna be reviewing everything, just some aspects on the binomial theorem and some aspects on transformations of functions. And also I'm gonna be teaching you how to handle the TI in regards to the binomial theorem and how to get the binomial coefficients quickly. So let's start. How to find the binomial coefficients using the TI. First, I'm going to assume that you have already the calculator, and if you don't have it by now, what you can do for the moment is type this on Google, TI Inspire software. You're going to be shown this page. You're going to be here. You're going to be clicking on this, and you're going to be downloading the software. It's a 30-day trial version, whether you use Apple or Windows. Now, do you need to do this? No, if you have the TI already, you don't have to download this thing. It's only for those that still do not have the TI. If you have the TI, all you have to do is turn it on and manipulate it in the way that I'm going to show you. So I have the software installed in my computer already. And this is the layout that you're going to be shown when you use that software, right? This is the calculator, as you can see it on your hands, right? All the keys, etc. And this is the display of the calculator. So this is home. This is home, which is obtained by clicking on this particular key, home. So let's click on this. We are in here. And let's add a document of calculator. This is the one for calculator in order to calculate arithmetic, that type of things, those type of things. And this is the document 1.1, and we're going to be working in here. Okay, so find 5 choose 2, right? That's how you read this, 5 choose 2 using the TI. So remember guys, what is this? This is the number of combinations. I mean, the way you pronounce this is 5 choose 2, but what is it? It's the number of combinations that you can get by having 5 elements and choosing them 2 by 2, right? Okay, so how do we do this? We can use the formula that I provided you, and with the TI, what we can do is the following. You need to go to menu, probability, combinations, and you're gonna be getting this structure and choose R, right? Remember, this is the same as when we write the symbology. I told you that there are several symbologies in order to represent the same aspect. So and choose R. We need to write 5, comma, 2, close parentheses, enter. And we're going to be getting 10. So 5 choose 2 is going to be 10. And you can actually check by using the formula that I gave you, right? The one with factorials and so on. That's how you do it. So basically, this first task is achieved in that way. The second, find 5 choose 0, 5 choose 1, 5 choose 2, all the way to 5 choose 5 with the TI. There's a way to do this very quickly, guys, because I don't want you to imagine that this is the task that you have to perform, getting all these binomial coefficients. Remember, these are also known as binomial coefficients, because when you expand a binomial to any given power, these things will be appearing at the beginning of each term, right? That's why they're known as binomial coefficients. Okay, so you're not gonna be doing this, guys. You're not gonna be like menu, probability, combinations, and then 5 choose 0, parentheses, enter, and then the next one, right? By the way, you can also do this. You can write n choose r, parentheses, 5, comma 1, enter, and the calculator also understands this symbology. Basically, when you write NCR using the keyboard and all of this structure, it will understand what you're trying to do. You're trying to calculate and choose R. So you're not going to be doing this, right? like every single time, like and choose R parentheses and then 5 comma 2 parentheses. I mean, sure, you can do it, but there is a faster way to do this, which is the following. Click on menu, click on probability, combinations. You're gonna be receiving the structure for n choose R. And what you need to do is this. You need to write 5, comma, and what I want you to do is this. In this key, guys, you see the parentheses, the circular parentheses, but right here on top, this thing right here, this is a structure for braces, So how do you obtain this structure? All of these structures on top of the main keys are obtained through control. So I press control, and then I press that key, and you will be getting that structure for braces, right? Like so. And what you need to do next is write all the values of R, which is 0, 1, 2, 3, all the way up to 5. So that's what I'm going to do next. I'm going to write 0, 1, 2, 3, 4, 5. Then I close the parentheses. By the way, right now, as you see me doing this, guys, what I'm using is my keyboard, right? For example, you don't see me typing, like when I do this, 0, can you see that? I'm using my keyboard, the keyboard of my computer. But because I think that clicking on these keys is way too much work. So I can do this. Then I close the parentheses, I press enter, and this is what you get. You get this structure in within braces, and this is telling you that all the basically 5 choose 0 is 1, like we can see it here, and then 5 choose 1 is 5, which is this one, you see, and then 5 choose 2 is 10, which is this. So you see, basically it's giving you all of them automatically, so that you don't have to do them one by one. So there you go, and that solves this particular task. The next, expand this binomial using the TI, with the help of the TI. So let's see. Let's first minimize this thing a little bit. Okay, so we have this to the 7. And how can I use the TI? Well, I can use it in order to calculate the binomial coefficients, right? Because if you remember, when we have a binomial, 7 in this case, you're going to get at the very beginning all of these binomial coefficients, 7 to 0, and then the first number to the 7 times the second number to the 0, and so on, right? So how can you use the TI in order to make this a little quicker? Well, by getting these numbers with, with the TI, right, very quickly. So let's get them. 7 choose 0, 7 choose 1, 7 choose 2, and so on. Once again, how do you achieve that? You achieve that by using this pathway, and then you write 7, comma, control, and then this key, and then 0, 1, 2, 3, 4, 5, 6, and 7. You close the parentheses, you press enter, and these are all the coefficients, all the binomial coefficients, 1, 7, 21, 35, and then remember that there is symmetry. There's always symmetry in the binomial coefficients, right? So 1, 7, 21, 35. Okay, and that's it, right? I'm just gonna be replacing those things, those coefficients in here. It's gonna be 1 times all of this to the 7, 2 to the 7 times x to the 14, and then all of this to the 0, that's gonna be 1. These were the coefficients, right? Okay, and basically that's how you can use the ti. Then 2 to the 6, x to the 12, and so on, right? I'm not going to be doing this all the way, but now you know how to use a ti in order to expand any binomial to any power. And then obviously you can use it also for calculating 2 to the 7, 2 to the 6, 2 to the 5, and so on. Okay. And finally, find the coefficient of the term in x to the 5 of the expansion of this binomial to the 10. So let's see. Let's write down the binomial to the 10, right? And I want to find the coefficient of the term in x to the 5th. How do you find that term, guys? Well, once again, if you want, begin with maybe a couple of terms. You're going to get this. That's the first term. This is the second term. This is the third term. Right? And so on. So as we can see, let's look at the variable parts of all of these terms. Only the variable part. The variable part of this term will be x to the 30. I'm just focusing on the variable part. X to the 3 to the 10, I'm going to be getting this. And then x to the 3 to the 9, I'm going to be getting x to the 27. X to the 3 to the 8, I'm going to be getting x to the 24, right? So as you can see, this for the first term, we begin at 30. For the second term, 27. For the third term, 24. And we go by jumps of -3 units, right? So how many do I need in order to arrive to this, right? To x to the 5. I actually made a mistake in here. I had give me a moment. This is not what I meant. I meant 15. Okay, that's what I meant. That's a typo. Okay, so which one is it gonna be? Which one is it gonna be in the end? How many times do we have to go down? Let's see, it's gonna be 30, 27, 24, and then 21, and then 18, and then 15. So that will correspond to the sixth term, right? First, second, third, this is the fourth, fifth, and sixth. It is the sixth term that will contain, that will be the term in x to the 15, the sixth term. Okay, so we need to look up for the sixth term. How do I do it? I use my formula for finding any specific term. If the binomial is this, a plus b to the n, and if you want to find any given particular term, then use this formula, right? And substitute the r for the given number of terms that you're looking for. So in this case, r should be 6. So you will be trying to find this term. Oh, and by the way, we can already replace n, right, for 7, well, for 10. And then the first number is 3x to the 3. The second number is minus 5, 5, and 5. Okay, that's going to be, when you substitute 6 in here, and obviously n equals 10, because that's the exponent that you have here, then you're going to be looking at this specific term. That is the sixth term. That is the sixth term, and that's going to be the term that contains x to the 15, as you can see clearly from this, right? X to the 3 to the 5, 15. Then calculate this with the TI, whatever number that is, multiplied by 3 to the 5 times minus 5 to the 5, okay? And you're gonna get some coefficient. I don't know how much that is. It's not, do it on your own. And then times x to the 15, right? And that's gonna be the term in x15 of this expansion. So there you go. Okay, now if I have some time in a moment, I'm going to be addressing this one here, but let me jump to how to graph a function with the TI. So what you do is this, guys. What you do is go to the TI. Let's go to home once again. And now let's open a document of graphs. Like this. A new document appears, 1.2. And we have this structure, f1 of x equals blank. Okay, so how do we graph? It's very simple. Let's suppose we want to graph the parent function of the quadratic function. So we're going to do this. You're going to write x to the square, enter, and there you go. It's actually that simple, right? You're going to be showing the graph and this label, which you can actually move it around. And the way to move it around is you have to press on this key and then hold it. Hold this key until you see this, until you see that the hand is like that. See what I mean? And then you can move it around to any position you want. You don't have to, but you can. And then release by pressing on the button once again and holding it. Okay? So that's how you draw. All right? It's that simple, guys. It's that simple. If you want to draw once again another function, just go to home, go to the same icon, and then once again just draw, right? Like x minus 3 close parentheses to the square minus 1, press enter, and this is it, right? This is the function, as you can see. From the label of the function, you can see that what is happening here, if you understood what we saw about translations, then you can realize that this minus 1 is causing a vertical translation of 1 unit downwards, right? So as you can see, it's downwards. And this minus 3 in here is causing a horizontal translation of 3 units to the right, which is from here to there, 3 units, 1, 2, 3, right? There you go. Okay, so that's how you draw, guys. Let me make a little pause. I'll be back with you in a moment. Okay, let's continue, guys. I had to make a little stop right there. So that's how you graph, guys. Oh, and by the way, how do you graph? Wait, sorry. How do you graph two functions on the same sheet, right? On the same set of axes. All you have to do is, if you have one function already, right, like here, all you have to do is go to menu, entrada de gráfico, option number 3. Sorry, escape. Once again, menu, entrada de gráfico, and then you need to graph once again another function, right? And then this other subindex will appear, f sub 3 of x, because you already have f2. This is f2. This is to give functions a specific name, and now f3 of x. Let's draw the parent function. X squared, enter, and then we have this the parent function of this one, right? Like you can see in there. Okay, so that's how it works, guys. That's how graphing works in the TI. If you want to eliminate this document, just press on this key right here. And if you don't want to save the document, just press no. And you will be returning to home. So basically, this is a calculator in order to do, any type of calculations. 12 to the 3 minus 6, enter, and so on, right? So that's how you do it. I'm going to be teaching you things slowly but surely, okay? Beginning right now. We're going to use it probably not every day, but perhaps 70 or 80% of the time. We're going to be using the TI. So I want you to bring it in every single class. I want you to have it in your school bag, basically. Okay, now let's get to solve these two problems right here on transformations of functions. Let's see. Number 1, given the parent function f of x equals x squared, write the function g that it is a translation of the parent function 3 units upwards and 2 units to the left. Okay. So in here, guys, they're giving me the parent function, which is this one, and it appears right, right in the middle of the Cartesian plane, right? It's just like this. The graph of this is going to look like this. And then they tell me, write another function g. This is f, guys. You must understand that. This is f of x equals x squared, which is the parent function. And write the function g that it is a translation of the parent function, which is this one, 3 units upwards, 3 upwards, and 2 units to the left. 3 upwards and 2 units to the left. So how should that function, uh, how is it going to be looking like? Okay, like what should I put in here? How should I write it? How should I write that function? Well, let's see. First, let's apply the horizontal translation. 2 units to the left. So in order to do that, I need to change x for x plus 2 to the square. Remember, when we talk about horizontal translations, when we add, the parent function will move to the left as many units as you are adding. So this will cause this translation. 2 units to the left, what I just did. And then 3 units upwards, all you need to do is add 3 units, right? In order to move the parent function 3 units upwards. So this is what g of x should be in order to satisfy these requirements. And let's see if that's true. Once again, let me go to the TI. Let's go to home. Let's click on this icon, f1 of x, and I'm gonna write what I said. Plus 3. Was that the case? Yeah, that's right. So let's click enter, and there you go, right? That's function. It's 2 units to the left, 3 units upwards. Like I said here, 3 units. Wait, no, did I make a mistake? 2 units to the left, 2 units to the left, 3 upwards. Yeah, that's right. So in fact, this is the function. This is the function g. Now, the ti automatically gives you the variable f or the name f for any function that you want to plot, right? It doesn't at first it doesn't allow you to, like, this is the default. This is the default name. That's what I'm trying to say. Okay, so that completes this problem. Number 2, let's see. Some vertical and horizontal translations have been applied to the function f of x equals x squared, giving as result the function g shown in the image. So this is a function g, which is a transformation on this parent function that I'm not showing you in here. Write the equation of the function g. I would have been more, I think this is better. Write the equation of the function g. So all I need to do, guys, is analyze what happened to the parent function. If the parent function was in here, as we know, right, then I can see that the vertex was displaced, or the whole function, right, each of the points of the function were displaced 2 units to the right. I'm going to symbolize this in that way. 2 units to the right, and then 4 units downwards. You see? And therefore, I should know that that g should be written in the following way. Let's make first the horizontal translation. We move to the right, so I need to subtract in the x, like so. And then we displaced downwards, so that's going to be like so, right? X minus 2, all of that to the square minus 4. So this is going to be the function g, which satisfies this requirement, okay? So once again, if you want to check, just go to the TI, graph this function, and you should be looking at this same thing. Okay, So I think that's about it. Maybe yeah, no, I will solve these two problems maybe today, guys, and I'm gonna be uploading them in a moment for you, so that you can practice a little bit more. I already explained this one. For example, if I believe well, if I'm well, I already explained this one in all the classrooms or one of this type, right? But anyways, I mean, we can do it either in class or as a video, and these two, right? And also, I want to talk about this one right here because some people have been having some trouble with this problem, section 1M, problem 3. So I may as well make a video and explain this particular problem to you completely. So let me make that video, guys, and that's about it for the moment. Remember, in regards to transformations, in regards to the subchapters 3.3, I'm just gonna be testing you on translations, only translations, no reflections and no stretches of none of those things. Just translations as simple as these two. That's all. So thank you, guys.